Okay, hello everyone. I'm Rafael do Nero. Boa tarde para todos. Today is my first time in JNation. I'm very excited to deliver the talk about the Java challengers. And if you want to follow me, Rafael do Nero, you can follow me, and then I'll be sharing Java challenges there. And you can take a look. There are more than 100 Java challenges. So you can solve them, and you can get better with your Java skills. Okay? So to get the full benefit of this talk, I encourage you to download the code. If you are with your laptop, you can download the code. You can try out the Java challenges so that you can fully absorb the concepts. The code format, like you're going to see that they are like not so well formatted because I had to fit the code in the screen. And also no planets were harmed in the making of this presentation, so don't worry. OK, so let's go. So I'm going to give you the summary of the Java code challenges. So we're going to go from JDK 6 to JDK 17. And as you can see, there are a couple of key features like DQ, auto-closable, list string, lambdas, modules type inference, which it is the var. And then the switch case statement, text blocks, records, instance of pattern matching, and then the sealed classes. OK, so let's go to the little story here. So from 1996 to 2010, there was the sun orbiting here. So during those years, Java was chilled from Sun Microsystems. And in 2010, the red giant succumbed Sun, and the innermost planets were obliterated. And in the present day, we're going to explore all of those planets since JDK 6 to JDK 17. So Duke is there. OK, so let's start from JDK 6. So this is a Java challenge. As you can see, we have a couple of methods here, add first, push, and add last. And then we are showing a couple of data here with the sysout. So I'm going to show you the alternatives. So there are 4 alternatives. So I'm going to give you around 1 minute to think about the answer, OK? OK, who thinks it's A? Raise your hand. B? B, OK. C? OK, and D? OK, so let's see the answer. Duke, come on. OK, so it was D. So the DAQ interface is very important because you can use both of like very important data structures. That is the stack, which uses the structure LIFO, and the queue that uses the FIFO structure. So if you've been doing interviews nowadays, you're going to see that they are asking a lot about data structures. And it's very important for us to master those concepts. Stack and queues, like those are fundamentals. And those are very important. And the DQ interface in Java implement all of those features under the hood. So OK, let me explain here why it's D. As you can see, we are using the add first method. Then Wharf will be added. And then push will be added on the top. And then Scott will be added at last. And then Odo will be removed. And then the pick method will just pick the first element, but won't remove anything. And then the pop will remove Worf, and the poll will remove Scott. Okay, JDK 7. So here, Java was absorbed by Oracle. Okay, so this feature, so why this feature is important? This feature is important because it reduces the boilerplate code. So instead of having to close your resources in the finally block, you can simply use the try with resources feature. Okay, so as you can see here, we have the ship door challenge class, and then we are implementing the auto-closable interface. And as you can see, we have the close method here. And then the main method, we are doing a couple of operations with the try with resources feature. So let's see the alternatives then. Oh, before that, who works with Java 8 here? What about Java 11? Okay, it's the vast majority. That's very good. What about Java 17? Awesome. Yeah, that's very nice to see that there are developers working with Java 17. Okay, so let's see the answers then. Okay, who thinks it's A? Who thinks it's B? C? And D? Okay, let's see the answer then. And guys, don't worry if you get it wrong, because those questions, they are tricky. So let's see the answer. Okay, it's C. So why it's C? So it's basically the order of execution from the try with resources feature. So firstly, the open method will be invoked inside the try with resources block. And then, as you can see, we are throwing a runtime exception in the open method. And then the close method will be invoked. Why? Because we're using try with resources. So we are just printing this information, ship door is closed. And then we are just printing the exception message, which is fail to open door. And then the finally block, we're going to just print the end. So this feature is very, like I said before, it's very useful if you want to close resources. And the JDK, there are many classes that already implement auto-closable. So you don't need to implement anything out of the box. It is already there. So you can reuse a lot of things. Like you can, there are many examples in the file framework and also in the JDBC classes. You can use those things for free. Okay, so let's go now to JDK 8. It's an LTS version. What does that mean? It means that it's a version that the Java vendors will be maintaining for longer. So it's easier for you to use it in production. Okay, so this is a challenge about streams and Lambda. So yeah, it's pretty simple here. We're just creating an array list. And we are using some methods in the stream here, pick, limit, and for each. So let's see the alternatives then. OK, who thinks it's A? OK. B? OK, C? And D. OK, so let's see Duke then. Duke, come on. It's A, congratulations. Most of you got it right. OK, so the important points here about streams. Like the important points are the intermediate operation methods. So those methods, they don't do effectively any action, which means that they prepare the data in the way you want. And there is also the terminal operation methods. A very good example of those methods is the for each and the collect method. So basically, those terminal operation methods are the methods that will retrieve information or will effectively do something with the data. Another very important point is that without any terminal operation method, nothing happens. Why? Because streams are lazy. So, OK, so let's see why here it's A. So the pick method will just print information. So we're going to get Kirk. And then we're going to print Kirk in the for each method again. And as you can see, we're not printing 3 elements. Why? It's because streams are lazy. So it won't waste resources running through 3 elements, since we are using the limit method to. So it's going to just run through 2 elements. So we're going to print the element with the pick, and then in the for each method. I highly recommend everyone to take a look at all the intermediate operation methods so that you can manipulate the data better. And I think those are the most important concepts for streams. OK, so now it's the doors challenge. And as you can see, we are doing an operation with a lambda expression, OK? So I'm going to show you the alternatives. Who thinks it's A? Who thinks it's B? Who thinks it's C? Who thinks it's D? OK, so let's see the answer. Duke, come on. OK, so it's a compilation error. So why it's a compilation error? So it's because lambdas, by its essence, try to follow the functional programming paradigm, which means that data should be immutable. We shouldn't be changing data inside a lambda expression. So which means that the variable should be final or effectively final. So what is an effectively final variable? It's a variable that has a value, and it's never changed. So if we don't change an external variable inside the lambda expression, it's OK. Like if we didn't have this door number plus plus, if we didn't have the plus plus sign, it would be OK. This code would compile fine. So basically, just remember that by essence, in a lambda, we shouldn't change external data. It should be a pure function, which means that every time you invoke a pure function, it should always behave at the same way. It shouldn't change anything. So that's why we can't change external variables. So that's it for this lambda expression challenge. Let's go to the next one, JDK 9. OK, it's a short-term hyperbolic orbit. OK, so take a look at this diagram, because we're going to need to memorize it to answer the following question. As you can see, we have two modules, Risa and Vulkan. And notice that one module is using each other. OK? I'm going to give you just a couple of seconds just to memorize that. OK? So let's go to the next slide. OK, I'm going to give you a brief of this challenge just to help you out with the answer. So as you can see, we have two modules, the module Risa. And the module Risa, we have the class executor. And in this class executor, we are using the Spock class from the module Vulkan that is in the bottom. And as you can see, we are using also a reflection operation here. OK? And in the Spock class, we have the tag private method and another public method. So I'm going to show you the alternatives. OK, who thinks it's A? OK, who thinks it's B? And C? And D? OK, so let's see the answer then. Come on, Duke. OK, so it's C. Congratulations. OK, so the problem here is that we are trying to break encapsulation. So with modules, we have this great benefit that we have real encapsulation. What does that mean? It means that even if you want to break encapsulation with reflections, we will have an issue here. We have the exception inaccessible object. So we can't do that with modules. So this is a great benefit with this new feature we have with modules. OK, so since we can't break encapsulation, we couldn't do a set accessible true and invoke the attack method via reflection. So what could we do here instead? Like in the modules feature, we can use the opens clause. The opens clause will open the package for us to access via reflection. So here it's totally fine. If we added this clause to the module Vulkan, we would be able to use the private method via reflection. And the benefits of using modules is that modules, like you can create a lightweight application with modules because you don't need to import all the ecosystem from Java. And you also have strong encapsulation. And it's also amazing to add new features in Java because Java, like before Java 9, was a big monolith. So it was very hard to add new features. So with modularization, it's also easier to implement new features in the Java language. Perfect. So let's go to the next one. JDK 10. Oh, guys, and I forgot to mention, in the end of this presentation, there will be a special gift for you, OK? OK, so JDK 10. So JDK 11, it's the long-term version, and as I saw here, most of you are using Java 11, and this is kind of the new default in the Java market. So it's very important to know all the features we have in JDK 11. So this is a bit of a big challenge, but here the main feature we're going to be exploring is the type inference with var. So you can see that we are using anonymous inner class with the name of var. We are using also a variable named as var, and we are printing some data in the end of this challenge. We are doing also a very strange casting here, which I'm not sure what's going to happen. So let's see the alternatives. How things great. So let's see the answer then. Come on, Duke. Okay, it's B. Yeah, like I said, it's not recommended to do that. But with var, we can assign null to a var by doing a casting. So, and that makes sense. Since var is a type inference, it will be inferring that it's the var type we created above here. So as we can see here, we have the interface var. And on the top, we are creating an anonymous inner class here. So we are instantiating an anonymous inner class for the var interface. And we are implementing the collide method. And this is totally possible. Like we can assign null to a var only by using casting. Since it's a type inference, that makes sense. And as we can see here, we can also use the var variable name. It's totally fine to use var as a variable name because as you can see, like in the most recent Java versions, we are not creating keywords that will cause compilation errors anymore. So you can use var as name and like all the other newest keywords in Java, you can use as a var name, for example, or a method name if you want. It's not recommended, of course, because var doesn't mean anything. So it's always better to give a meaningful name to a variable. But I'm just showing you that it is possible to use var if we want to. OK, so we are also removing an element, and notice that we are using like this remove method in the overloaded way. So we're gonna print here the like Kirk Spock, and then Darth Vader. And what's gonna happen here is that instead of passing the primitive int, we are passing the wrapper int, which means that we are removing the object instead of the index. So that's why we have at the end 3 and 2. Okay, so let's go to the next one. Okay, UDK 14, this is the new switch case statement. Okay, so as you can see, we have the get Vulkan survivors method, and we are passing an enum. And then we are doing a switch case statement with Spock data, Michael Addington, and the default. And as you can see, we are doing Lambda operations here in the new switch case statement. The cool things with the new switch case statement is that you don't need the break keyword anymore, and you can even return data right away if you want with the new switch case statement. So let's see the alternatives. Okay, who thinks it's A? B? Okay, C? And D. Awesome. So let's see the answer then. Come on, Duke. Oh, it's B, okay. So like I mentioned before, the important points about the new switch case statement is that we can return a value right away, and that makes our code cleaner. So it removes the boilerplate code. And another great benefit of using the new switch case statement is that we don't need to use the break keyword anymore. And I know that we didn't get at the pattern matching challenge yet, but we can use the switch case statement with the pattern matching as well. And then we can make the code even cleaner. And as you can see, when we have more than one line in the case statement, we have to use the yield keyword. And this yield keyword will basically just return the data. It doesn't do anything else other than that. OK, so those are the important points about the new switch case statement. And as you can see, in the first get Vulkan survivors, we are passing Spock. So it's going to go into the first section of the code, case Spock or data. And then notice that we are using the value of method, which returns a new integer. Well, we have a new integer as an object, but when we do a comparison between a wrapper and a primitive number, what happens is that the wrapper will be converted to a primitive type. So 2 primitive types are equals. So it's going to return 10 here. And then in the second get Vulkan survivors, we're going to compare a string 6 with a new string 6. Notice that when we use new string 6, the JVM will create a new string object in the memory heap. Even though they are the same value, even though they should be like the same object, they should be the same object because like there would be a string pool. When we force and we say, OK, new string, we are forcing the creation of another object in the memory heap. So which means that it's going to be false. So those objects will be different. Those are different objects. And then in the end, we just pass not the Allen Garrick, but it will go into the default. And notice here that we are not throwing any exception. We are just returning an illegal state exception object, nothing else. So, which means that we are going to just print the object name and no survivors. Okay, so next challenge. Let's go to JDK 15. It's another short-term version. And this is the awesome text blocks feature. So why it's so cool to use this feature? Because you don't need to put a lot of plus on your code. And this is very useful. I see this a lot in real applications. I see SQL code. And it's really ugly to me to see all of this SQL code concatenated with a lot of plus signs and makes the code really unreadable. Or like even worse, when you see a huge line and you have to scroll all over the code to see the whole SQL code, that's horrible. So it's much better to use text blocks. It makes the code so much cleaner, and it removes a lot of the boilerplate code. So as you can see here, we have an example without the text blocks. So we are concatenating them. You can see that's pretty ugly. And then with text blocks, it's all nice and neat. So we have the JEDI without text block, JEDI with text block. And then we're doing some operations in the system out statement. So let's see the alternatives. OK, who thinks it's A? Awesome. Who thinks it's B? Who thinks it's C? And D? OK, thanks, guys. So let's see what Duke says. OK, Duke says it's C. Awesome. So there is something here that's very tricky. It's the order of execution in Java. So there is a method precedence here. So what happened is that the strip and the formatted method will just consider the last string. Because as we can see here, we are creating 4 strings objects. Because every time we use the plus sign, we are creating a new string in the memory heap. So what happened is that the JVM will just consider the last string. So this last string /HTML. So which means that it won't substitute this %s. So it will continue %s in the JEDI without text block. And with the JEDI with text block, this is totally possible because it's just one string. So look will be substituted by the %s. And then we're going to compare the JEDI without text block if they are equals to JEDI with text block. And of course, they'll be different because the JEDI without text block didn't get substituted because of the method precedence in Java. But then after we invoke the formatted again in the last statement here, it's totally fine because this string is already concatenated, which means that those are equals now. So we have false and true. So that's why this is the answer. So let's go to the next planet. JDK 16, another short-term version. So this is the record feature. So the nice things about record is that you can create, you can reduce a lot of the boilerplate code. Why? Because you have for free the equals and the hash code methods, the get method, and you don't need also to recreate a constructor. You can just use this kind of new type of constructor. So it's very clean and neat. OK, so as we can see here, we are using the commander record. We are using generic type. And we are doing a couple of operations in the main method. OK, so and we also have a strange kind of constructor here. And we are doing an operation here. OK, so let's see the alternatives then. OK, so who thinks it's A? Who thinks it's B? C? And D. OK, let's see the answer then. Duke, come on. Congrats, guys. So yeah, it's C. So the first thing to notice here is that you can use a generic type if you want in a record. And this is this strange kind of constructor I said. It's the compact form of canonical constructor. So usually what you do in this kind of constructor in a record, you handle some invalid data. So possible invalid data, you can just do some validations here. And another thing is that we are creating a record inside the main method. So it's totally possible to do that. And at the end, we are comparing the commander. If it is equals a new commander, and then we are passing the new ship record that we just created in this main method. And this new ship, like we can pass that because we are using the generic type T, and we can pass anything to this generic type. But notice that a record is not serializable by default, which means that our canonical constructor will check if our ship is instance of serializable. It's not, so it's going to throw the runtime exception. So that's all for this record challenge. So things to keep in mind is that it's nice to use record because you reduce a lot of the boilerplate code. You get the constructor for free. You get getters for free, hash code and equals method for free. So you don't need all of those boilerplate code. OK, so this is the instance of pattern matching challenge. As you can see, like this number is a bit strange. I already tell you, like this first shoot, there's something weird in this number. I'm just giving you a tip. So we are just like we are overloading the. Well, we're not overloading actually. We are just passing a lot of different types in the shoot method. And we have a couple of operations with instance of here, OK? So let's see the alternatives then. thinks it's A? Who thinks it's B? C? And D. OK, so let's see the answer. Duke, come on. It's D. Congratulations. So yeah, like I said, this number was weird, and it's not a typo. It's actually L. It's the L lowercase here, so it's actually one long. So here is being invoked, and when it's concatenated with a string, like a string is a comparable object as well. So it will go into this instance of comparable, and then we are just gonna check if they are equals, but 11 is different than 1L, of course. So it's I told you this number was weird. And then we invoked another time the shoot method with true. And what happened is that when you pass a primitive value true, which will be wrapped into a Boolean wrapper when you pass to one object, and which means that a Boolean wrapper is also a comparable object. And then it's going to print false again. And then we are passing a string buffer, which we also converted to a string, which means that it's going to go to the comparable again, because a string is comparable. And then in the end, we pass a runtime exception, which is a serializable object. So it's going to print just runtime exception. And as you can see here, guys, we are using the pattern matching concept in the second else if. So instead of doing class casting, we can just declare the comparable object at the end of this else if. So it makes the code cleaner as well. So I don't have much time, and I think I'm going to skip this challenge for now, or we can go very quickly on it. So, well, I can give you at least the main concepts of sealed classes, like why would you use sealed classes? So sealed classes are important because, like, you can restrict your code. Like in your code design, you can say, for example, if you have a parent class vehicle and you want only a truck and a car class to extend this vehicle class, you have total control. Why? Because you have these special clause permits. So you have this control. Fortunately, I won't be able to go through this challenge unless I have more 5 minutes. OK, so we can go through this one very quickly then. So yeah, we are using the permits clause, implement. OK, let's see. Let's see the answer. So the answer is C. Why? It's because, as you can see, the JNation class is not defined correctly. It's not final, and it doesn't implement captain. So every time you use permits clause, you have to, like the class in the permit clause has to be final, or it has to implement the parent class. So there are some rules with sealed classes, and like I said before, sealed classes are important for your code design. And you can also use pattern matching with sealed classes. So instead of, like, for example, you don't need the default clause in the switch case statement, because the Java compiler will know already that, for example, the captain can be only Spock, Saru, or Janeway, nothing else. So you don't need to create redundant code. So this is a very important concept as well. and we can use it. So we talked about the queue, auto-closable list stream, Lambda for each modules, type inference, switch case, text blocks, sealed classes, record, pattern matching. And if you want to get more challenges, you can follow me on Twitter, Rafael Nero. And OK, now that I finished my talk, who is me? So I'm Rafael Nero. I'm the author of the Java Challengers book and the Golden Lessons book. I have more than 10 years of experience in the market. I'm the creator of the Java Challengers initiative. I'm a Java champion, and I'm an Oracle ace as well. OK, so that's pretty much it, guys. And that's the gift I promised you. So you can use this QR code, and you can get this book for free. So there are 5 challenges there. I handpicked those 5 challenges so that you can have an easy win with your Java learning. So you can get better with streams optional, all the nice, cool features we have in Java. So it's totally free. You can either access the QR code or you can access the link, whatever is better for you. And that's pretty much it, guys. Thank you very much. I'm really happy that you all have been here, and I'm very grateful for your presence here. Thank you so much.